all of you. I welcome you, Dr. Aditya sir, on behalf of Degree Institute of Engineering and Management Study. Basically, today we have Dr. Aditya sir from the Bajaj Institute of Technology, Wardha. He is currently working as a assistant professor in the particular institute. He has 15 years experience in water resource engineering. So uh, I like to hand over the mic towards the Aditya Nilawar. Sir, you can start the session.
Shall I share, sir? Shall I share it?
Yes, yes, sir.
Sir, is it visible? Hello?
Yes, sir, it is visible.
Shall I start?
Yes, yes.
So, good morning, one and all present here, respected faculty members and dear students. So, it's a pleasure to be here with you all. My name is Aditya Nilawar. I'm currently working as an assistant professor at Bajaj Institute of Technology, Wardha. Today, my topic of discussion is aspects of hydrology and its application. So, my outline of presentation is first we'll discuss about hydrological cycle and its components. Then, as you know, it is very you can say you have already know about the what is hydrological cycle and its components. Still, some glimpses of hydrological cycle we'll discuss. Then we'll move to precipitation and its form. Then we'll discuss about water balance. So it is the key factor, as you know, water balance is the key factor for overall hydrological process, and we have to manage our resources based on water balance. Then followed it by we'll discuss evaporation, transpiration, infiltration, and finally we end up with our presentation with runoff. So first we'll discuss what is hydrology. So hydrology is the science of water that is concerned with the occurrence, circulation, and distribution of water. So as you know, water is present everywhere. If you see, it is present in atmosphere, it is present on ground, it is present below the surface. But the water that is available on the surface or below the surface is, you can say, useful for us. So we have to manage our resources depending on our water balance, and the water present in the atmosphere, you can say it is an input for overall hydrological system. So as you know, what is hydrological cycle? So sun is the main driving force for overall hydrological process. Due to solar radiation, water present in the, you can say, water body get heated up or get evaporated, and once it get heated up or evaporated, it will collected in the atmosphere. Once it collected and condensed, again it will fall on the ground in a form of, you can say, precipitation, and this cycle is continuous. So this process is nothing but the hydrological cycle. So the water cycle has four stages. If you see, this water cycle has four stages. First is, you can say, storage, then evaporation, then precipitation, and runoff. So if you see here, what are the, you can say, 7 things involved in overall hydrological process. So sun is the source, main source of, you can say, which is driving the overall hydrological cycle, due to which water get evaporated from the source. Okay. Once it evaporated, it will reach to the atmosphere. Some amount of water also evaporated from the plant, which is nothing but the transpiration. Then once it collected in the atmosphere, it get condensed, and again it fall onto the ground in the form of precipitation. So 4 is nothing but the precipitation. 1 is evaporation. Then 2 is transpiration. 3rd is condensation of the air. Then 4 is precipitation. And after that, 5 is some amount of water get flow from the surface of the, which is nothing but the runoff, and some amount of water get infiltrate into the ground, and again it will reach to the source after a few days, which is nothing but the subsurface flow, or you can call the subsurface flow as delayed flow. So this is how you can explain the hydrological cycle. Then we'll come to precipitation and its form. So many times students get confused between rain and precipitation. Rain is a form of precipitation, and if you see the rain, it is the main form of precipitation in India. When the droplet size larger than 0.5 mm, it is called as rainfall. Again, further you can classify this rainfall as light rain, moderate rain, and heavy rain, depending on its intensity. So if you trace its intensity is equal to, if it is equal to 2.5 mm per hour, then you can categorize it as light rain. If it is between 2.5 to 7.5, then you can trace it as moderate rain, and greater than 7.5 you can trace it as heavy rain. The next form of precipitation is snow. It is made up of one or more tiny ice crystals that comes together to form a unique shape and snowflake. The next form is drizzle. If the particle size, or you can say water droplet size, is smaller than 0.5 mm, and if its intensity is less than 1 mm per hour, then you can categorize it as drizzle. Then hail. If the diameter of water droplet is 5 mm to 125 mm, then you can categorize it as hail. Then dew, so formed by condensation on the ground during night when the surface has been cooled by outgoing radiation. Then sleet, a mixture of rain and snow. So as picture is depicted, so this is nothing but the sleet. Then further, based on factor responsible for lifting of precipitation, it is process is classified as cyclonic precipitation, convective precipitation, and orographic precipitation. So cyclonic precipitation is caused by lifting of air mass due to pressure difference created in the area, and it is responsible for most of the winter, you can say, rain in Haryana and Punjab. Then again, you can categorize this cyclonic precipitation in two types. One is frontal precipitation. So when the moving warm moist air is obstructed by zone of cold air, and it rises to higher altitude where it gets condensed and heavy rainfall occurs. Then next type is non-frontal precipitation. So when air mass rushes into low pressure area, so your air mass gets flow from low area to higher area. So the air mass from low pressure area rises to higher altitude, and at higher altitude the air mass gets condensed and rainfall is occurs. Then next is convective precipitation. So you can see this precipitation in mostly tropical countries, where on particular hot day, ground surface is heated unequally and warm air gets lifted up. So the warm moist air is condensed at higher altitude, and rainfall of heavy intensity at shorter duration takes place. So you can call this as convective precipitation is occur when you can call this as unseasonal rainfall. Okay. Then orographic precipitation. Orographic precipitation is the most important precipitation and is responsible for most of the precipitation in India. It occurs when air mass laden with moisture strikes any topographic barrier and can't move further, so rise up and condense at higher altitude and causes precipitation. Then next is water balance. You can resemble this term with your bank balance. Okay, so some amount get credited in your account, some amount get debited from your account. So remaining is nothing but your bank balance. So similarly, some amount of water uh, get inputted in, you can say, in hydrological cycle, and some amount of water get out from the, you can say, hydrological cycle in a form of runoff and other losses. Remaining water is nothing but the water balance. So in hydrology, water balance equation describes the flow of water in and out of the system, and a water balance can be established by any area of earth surface by calculating the total precipitation input and total of the various output. So it is again one of the important, you can say, term for hydrology. Depending on what you can manage your resources, water resources. So by this we can account for hydrological cycle for specific area with emphasis on plant and soil. So if you see the equation for water balance, it is just a simple equation. Inflow is equal to outflow plus change in delta storage, or you can say change in storage. So it is very difficult to calculate the water balance for particular area because it is site specific. It depends on your soil type, it depends on your land use land cover, it depends on your constructed area, whether your land is impervious or not. So it depends on many factors. So it is very difficult to calculate water balance, and again it is site specific. So general equation for calculating water balance is P is equal to Q plus E plus delta S, where P is precipitation, Q is runoff, E is evaporation, or you can say evapotranspiration, plus delta S is nothing but the change in storage. So if you see, inflow consists of precipitation, surface inflow, subsurface inflow, then outflow you can categorize as subsurface outflows, subsurface outflow, evaporation, transpiration, evapotranspiration. Then storage delta is nothing but change in soil moisture storage, change in groundwater storage, snow cover, then surface storage, depreciation storage, etc. Then next we'll come to rainfall measurement. So as I told, it is one of the major input for hydrological system. It is very mandatory or necessary to calculate or measure the rainfall. So the measurement of rainfall is generally done by instrument called rain gauge, and this again classified in two types. First is non-recording type rain gauge, and other is recording type of rain gauge. So non-recording type of rain gauge, you have only one type, which is nothing but Simon's rain gauge. In recording, you have weighing bucket type, tipping bucket type, and float type rain gauge. So non-recording type rain gauge, so figure is depicted in the slide. So it is also known as Simon's rain gauge station, and its capacity is about 100 mm. So that the rainfall that occur at particular, you can say, instant or at place is collected in a bottle and measured at every 24 hours. And it is generally taken at 8 a.m. in our country, India. The next is non-recording type of rain gauge station. So in this type of rain gauge, the rainfall is automatically recorded on a graph paper by some mechanical arrangement. So when rainfall occur and it is collected in this bucket, once it collected, this spring arrangement or mechanical arrangement is there which gets shaped and which is connected with, you can say, a pen and graph. So once it shakes, your graph is generated. You can say mass flow graph is generated. So it is the most common type of self recording rain gauge, and the weighing bucket rain gauge essentially consists of receiver bucket supported by spring or any other weighing mechanism. The next type is you can call this as tipping bucket rain gauge. So a pair of buckets are provided uh, under the funnel in such a way that when one tipping bucket receives 2.5 mm of precipitation, it tips and discharging its contents into a reservoir and bringing the other bucket under the funnel. So this tipping bucket completes and you can say electric circuit, causing the movement of paint to mark on a clock driven revolving drum which carries a record sheet. Then next type is floating type rain gauge station, rain gauge. So the working of float type rain gauge is similar to weighing bucket type gauge. Funnel is received the rainwater which is collected in a rectangular container, and a float is provided at the bottom. Here you can see the float of the container. The float is rise as the water level rises in the container, and its movement being recorded by pen moving on a recording drum. When the water level in the container rises, so the float touches the top siphon, comes into operation and release the water, and thus the entire box is get drained. So siphon arrangement is placed here. Then you can say estimation of rainfall, or you can do the analysis of rainfall with different methods. So one is, you can say, arithmetic method, then Sisson polygon method, and isoheight method. So the most accurate method, you can say, it is isoheight method. So first we'll discuss what is arithmetic method. So this is the simple method of computing the average rainfall over a basin. So P1, P2, P3 are, these are nothing but your station where you can measure your rainfall at particular area. Then N is nothing but the rain gauge station. So if you want to calculate average rainfall at particular area, so this equation P bar is equal to P1 plus P2 up to Pn divided by N, where N is nothing but the number of rain gauge station, capital N. Small n is nothing but the number of stations in particular area. Then next is Thyssen polygon method. This is, you can say, weightage method. So the rainfall, as you know, it is never uniform over the entire area of the basin or catchment, but varies in intensity and duration from place to place. So thus rainfall recorded by each rain gauge station should be weighted according to area and it's represented. So for construction of the polygon, the following procedure is followed. So this is your area, P1, P2, P3, P4, P5 are, you can say, rain gauge stations. So you have to first draw a triangle from these points. You have to join all these points in a form of triangle. So this is like you are doing triangulation in survey. You have to join all these points in a triangle network. Then draw a perpendicular bisector from this triangle. Okay, so from this triangle you have to draw a perpendicular bisector. So what is its importance? So if you draw a perpendicular bisector, then polygon will form. See here, if I draw a perpendicular bisector, it forms a polygon. It forms a polygon, and you have to measure this area of polygon with the help of, you can say, planimeter, and finally you will get this type of diagram. So delineate the form of polygon and measure their areas using planimeter or by converting them into smaller rectangular geometric shapes, you can say, such as triangle, square, rectangle. So here, so P2 polygon, you have rain gauge station, then P3 you have one rain gauge station, P6 have area and rain gauge station. So finally, you will compute average rainfall by formula P1A1. So this is P1A1 plus P2A2 plus P3A3 divided by A1 plus A2 plus A3 up to AN, where A, capital A, is total area of the basin, A suffix I is area of particular polygon, and P suffix I is rainfall data for particular rain gauge. Then most important, that is iso height. So iso heights are nothing but, we can say, contours of equal precipitation or lines of equal precipitation. So an iso height map showing contours of equal rainfall is more accurate picture of rainfall over the basin. So iso heights are drawn on a map by method of interpolation after rainfall at each station is known. So it is little bit, you can say, clumsy method to draw iso height, and it takes much time to draw iso, but it is very accurate compared to arithmetic and Thyssen polygon method. So the area between the adjacent isoheights are measured with the help of planimeter. So let A1, A2, A3 be the area between these two isoheights, and P1, P2, Pn are the average precipitation for each pair of adjacent isoheights. Then P bar, that is average rainfall, is calculated using formula A1 in bracket P1 plus P2 by 2 plus A2 P2 plus P3 divided by 2, likewise divided by total area of the rain gauge stations. Then design of rain gauge network. So it is very important to know how much rain gauge are required in particular area. So optimum number of rain gauges are required in the catchment area is to give the correct average rainfall. So it should not be like, so it is very difficult to measure if you are placed number of rainfall station in particular area. And if it is less, so your estimation or calculation of rainfall is may get, you can say, wrong. So this number should be neither too many nor too less as to give unreliable result. So according to Indian standard, following terrain, you can say, gauge density is required. So if your area is plain, so one station you can put or place for 520 kilometers square. In region of average elevation of 1000 meter, one station for 260 to 360 kilometers square, and for hilly with heavy rainfall, one station for 130 kilometers square. So it depends on your area, how, if it is flat or undulated. If it is undulated or hilly, you can place one station for 130 kilometers square. An optimum number of rain gauge station is calculated. N is equal to CV divided by E whole square, where CV is coefficient of variation of rainfall value at the existing station, and E is the allowable percentage error in estimation of basic mean rainfall. The next is rainfall data presentation. Once you measure the data, it is next step is to present it. So a rainfall at place can be described if its intensity, duration, and frequency are known, and the intensity of rainfall is rate at which it falls. So first method of determining or showing the rainfall is nothing but the mass curve. So mass curve is nothing but the plot of accumulated precipitation versus time. It is the graph of accumulated precipitation, that is in centimeter, versus time, and it gives the information on duration and magnitude of storm. At particular instant, if you put here one point, you will get time and you can say a measure of precipitation. Then next is hydrograph. It is the plot of, it is not hydrograph, it is hydrograph, Hyetograph. It is the plot of rainfall intensity versus time interval. Okay, earlier it was accumulated rainfall versus time. Hydrograph is rainfall intensity, that is unit is millimeter mm per you can say mm per hour, likewise. So it is the plot of rainfall intensity against time interval. So hydrograph can be derived from mass of rainfall, and to draw the hydrograph, a convenient time period is chosen and corresponding accumulated rainfall is noted for mass curve of the rainfall. So this is, you can say, hydrograph. It is rainfall intensity, that is unit is mm per hour, and here time. So if you cut the time, or if you neglect the time, if you delete this time from here and from here, you will get the uh, rainfall in mm, okay, or volume of rainfall from this particular bar graph. Then next, this is about precipitation. Then we'll move to next, you can say, term, that is evaporation and its measurement. So evaporation is the process whereby liquid water is converted to water vapor by transfer of water molecules to the atmosphere. So water from this surface, or you can say water body, get evaporated due to solar radiation. And if you compare the transpiration and evaporation, the rate of evaporation is high compared to transpiration. So the bulk of this abstraction takes place during the time between runoff event, which is usually long. Then important thing that are, what are the factors affecting evaporation. So first is vapor pressure between water surface and air above, then temperature, atmospheric pressure, wind, depth of water, then water quality, size of water body, radiation, and humidity. Then next, measurement of evaporation. So the amount of water evaporated from the water surface is estimated by different methods. First is empirical method. Then next is water budget, energy budget, mass transfer, actual observation, and pan observation. So some empirical equations. So nobody knows how this equation comes. So only the, you can say, scientist or the person who derived this formula is known how this formula came. So we can call this equations as empirical equations. So many equations, Rover's Mede's equation is there. So I am not going in detail with this equation. I am just showing this. These are some empirical equations to estimate the evaporation. Next, water budget method. It is similar to, you can say, a water balance. How much water is coming in the system, how much water is going from the system, that you can calculate the evaporation. The next, pan measurement. This is, you can say, previous method are not that directly applicable in design problem, but you can use this pan measurement for particular, you can say, area. So again, it is site specific. It depends on various factors that how your area is evolved. So it having different soil type, it having different, you can say, land is land cover, different, you can say, constructed area, different plants. So it depends on very much, so much factor. So it is unique. So in most design problem, evaporation is measured by evaporation pan, which is called evaporometer. So it is a metal container with diameter varying from 300 to 1500 mm, and it is filled with water, and the water loss is measured at specific period. So the most commonly used evaporometer in India is US based or US Weather Bureau Class A fan. So this is evaporometer. Here you have to just pour water, and the water which is evaporated you have to measure in form of depth. Then next is transpiration. Transpiration is nothing but the loss of water from vegetation, or you can say a plant. It is the process of water moving through a plant and its evaporation from aerial parts such as leaves, stem and flower. So factor affecting transpiration is light, temperature, humidity, wind, soil measures and stages of plant development. Okay, stages means if your crop is few centimeter, so transpiration rate is, you can say, low. If your plant is much larger, then transpiration rate is high, likewise. But compared to evaporation, transpiration losses are less. Then one combined term is the loss of water is takes place from water body and soil and plant. You can call this evapotranspiration. So evapotranspiration is the sum of evaporation and the plant transpiration from the earth, land and ocean surface to the atmosphere. Its study is important in design of reservoir, irrigation canal and water body. So it is very important to know the evapotranspiration if we are going with study of water resource management, then water balance, etc. So the time unit can be an hour, day, decade, month, or even an entire growing period or year. Then some terms related with evapotranspiration is first is potential evapotranspiration. So many times students get confused between what is potential evapotranspiration, referential, actual. Okay, so it is the potential related with the potential of area. So if your area is covered with large, you can say, vegetation and having plenty of water, then you can call this as potential area, and the term refers with this is nothing but the potential evapotranspiration. It is the highest rate of evapotranspiration from an actively growing short height vegetation completely covering the ground with abundant water supply at a given climate. Then if your vegetation cover is little bit less, then you can call it as referential evapotranspiration. It is the rate of evapotranspiration not highest from an extended area completely covered by grass of 12 to 15 centimeter high, completely covering the ground. It is in the abundant soil moisture surface. Then actual is nothing but it is the actual evapotranspiration of a crop at particular locality at particular time. It depends on crop, soil and climate. Then factors affecting evapotranspirations are meteorological factor, and you can say meteorological factors are nothing but temperature, wind velocity, etc. And plant and soil factor. Then measurement of evapotranspiration. So there are two methods. One is direct measurement using lysimeter. Most popular that is lysimeter. Then field empirical method, soil moisture studies, integration method, and next is, you can say, empirical format. So lysimeter is a measuring device which can use to measure the amount of actual evapotranspiration which is released by a plant, usually a crop or tree. So by recording amount of precipitation, the water you can say collected in this receiver, the amount of loss to the soil is calculated. So evapotranspiration is equal to water added minus water percolated water. Then different empirical formula as I told. So Blenny-Friedel, then Christensen equation, Penniman-Monte. So again this is one of the most popular equation. Penniman-Monte method is used, or equation is used to estimate the evapotranspiration. Then we'll move to infiltration. So infiltration is defined as the downward movement of water from surface to the soil. Okay, so many times again students get confused between what is infiltration and percolation. If water is flowing from surface to subsurface, then you can call this as infiltration. Percolation is nothing but the change of stage of the water. So if water is moving from this soil to subsoil, soil to soil transfer. If water is transferring from soil to soil, then you can call this as percolation. If water is flowing from surface to the soil, you can call this as infiltration. The maximum rate of Then one thing, that is infiltration capacity. The maximum rate at which soil can absorb the water is known as infiltration capacity. And fill capacity, the volume of water that ground and soil can hold, is known as fill capacity. Again, these are very important terms for, you can say, overall hydrological modeling. Then factors affecting vegetation cover, moisture content, temperature, intensity of rainfall, human activity, quality of water, movement of man and animals, then presence of groundwater table, size and characteristics of soil particles. Then measurement of infiltration, you can measure this with single ring infiltrometer or double ring infiltrometer. It is just a simple instrument having diameter 30 centimeter and length is 60 centimeter. So you have to insert in soil up to 50 centimeter and 10 centimeter is above the ground. You have to fill the water up to 5 centimeter, and once it filled with water, water get infiltrated into the ground, and finally you will calculate infiltration rate by plotting a graph of infiltration capacity versus time. Then some drawbacks are involved in single ring infiltrometer. So water get lost from the sides of, you can say, a single ring infiltrometer. So to avoid this, one more instrument, that is double ring infiltrometer, is introduced. So it is similar to single ring, but one more ring is added around the single ring infiltrometer. So ring diameter 30 centimeter and 60 centimeter, and ring length is 25 centimeter. Ring driven into the soil is 15 centimeter, and water level maintaining 5 centimeter. Again, you will get graph, that is infiltration capacity versus time for double ring infiltrometer, and you can estimate infiltration. Then finally we'll come to you can say a runoff. So runoff, direct runoff and base flow. So direct runoff, it includes the surface runoff, then prompt interflow and precipitation on the channel surface, and base flow is nothing but the delayed flow. So in simple, if you want to say what is runoff, it is the graph of discharge versus time. Okay, and if you neglect the initial abstraction such as infiltration pi index, W index, then you will get surface runoff. Then short-term runoff and long-term runoff. So short-term runoff is storm runoff, period less than a week. Then application flood, urban drainage, erosion control measure. These are some applications of short-term runoff. Then long-term runoff yields period monthly, seasonal, annual. Then applications are estimation for capacity of storage structure and water supply management. So this is you can say stream flow hydrograph, or you can call this as runoff hydrograph. You have discharge on y-axis and you have time period on x-axis. Okay, so this is you can say a rainfall, and this is centroid of precipitation, and this, if I draw a line from the center of you can say P, you have rising limb at left and you have recession limb at right. In between this rising limb and recession limb, you have a peak. So once rainfall start, some water get infiltrated. So it will not rise from here directly. Okay. So once rainfall occur, some amount of, at the beginning, some amount of water get infiltrated. Once it reaches to its maximum capacity, slowly water starts flowing from the surface. So slowly your curve is rising, which is a rising line. Okay. At some instant period, you will get a peak, you can say surface runoff or discharge. After some time, as rainfall stops, again the water level or surface runoff get depleted. So you can say a recession limb or depleted limb on your right hand. So as again it reach to a normal level as your rainfall start or stops, and you will get a hydrograph of particular you can say instant. So if you neglect this you can say initial abstraction, that is base flow, the infiltration and pi index, W index, you will get the direct runoff, which is nothing but the direct runoff. And this is this hydrograph, or you can say a runoff, is used for different hydrological applications. So runoff estimation, so different or so many formulas are there. So here only rational method, that is Q is equal to CIA that is Q is peak discharge, C is runoff coefficient, I is average intensity of rainfall, then time of concentration, area is mentioned here, Q is equal to Ci. Then lastly, we go to hydrological applications. So you have vast applications of hydrology. So if anyone interested to do project in hydrology, they can select any one topic from it. So you can determine the water balance for a region. Then you can predict the flood. So once you get this data, that is hydrograph data, you can do all the applications of hydrology. So our aim is to calculate this hydrograph. It depends on what? It depends on your input data, that is precipitation, then water balance and losses in the form of, you can say, evaporation, transpiration, infiltration. So finally you will get this type of hydrograph, and which is used for different applications of hydrology. So you can determine the water balance of a region. So you can select one area and you can find out the water balance depending on how much rainfall you are receiving in that particular area and how much water is lost from that particular area. Then you can predict the flood. So depending on your hydrograph, you can predict how much flood will occur in coming year by using you can say different climatic tools. You have to just input your precipitation and temperature data. You can predict the floods. Then design of buffer zone. So if flood comes, it will come to some area, it will impound some area of this land. So you can predict, if you predict this flood, you can easily design this buffer zone. So depending on this buffer zone, you can demark how much water get raised in particular land. Then determining agriculture water balance, it is similar to determining water balance for a region. Just some few factors you have to incorporate in agriculture water balance. So types of soil, etc., etc. Then assessing the impacts of natural and human includes in environmental change on water resources. So if I give one example, if earlier this was you can say agriculture area, if I construct some you can say if I construct this area with some house, then buildings, then this area get impervious. So if area get impervious, then your infiltration is zero. Okay, all these factors become a zero. Infiltration, majorly infiltration is zero, and water start flowing from this surface. So this is the main you can say human activity which disturb your overall hydrological process. So you can assess this impact of natural and human included environmental change on water resources. Then design of irrigation scheme. As I told, water balance is key factor for overall hydrological process. So depending on how much water you have, you can design your irrigation scheme. Then designing urban drinking water and sewer system. So this you can do with the help of how much water you are draining from that particular drain. You can design your urban drinking water and sewer system. Then assessing the exports of sediment and nutrient from the field to water system. Again, this is one of the important thing to assess the sediment loss in particular area. As our land is get deforested, so much you can say what sediment get flow with the water, and which reduce your capacity of dams. So these are some applications of hydrology. So this is from my side. Thank you. So if anyone have any questions, so let me know.
Now I would like to call Nirvay for the vote of thanks. Please come forward.
Good afternoon, everyone. I, Nirve Suresh Sharma, feel immense gratitude to express the vote of thanks. I take this opportunity to thank Dr. Aditya Nivalkar, sir, Assistant Professor, Bajaj Institute of Technology, Wardha, for contribution his knowledge for second year civil engineering department students. I extend my gratitude to the Head of Civil Engineering Department, DIEMS, Dr. G.R. Nande, for his continuous support and motivation for successful conduction for this expert talk. I also thank Dr. A.S. Patan, Associate Professor, DIEMS, for arranging expert talk. With the permission of speaker, I declare the talk is over. Thank you.
Okay. So I would like to thank Director HOD and Pathan sir, Dr. Pathan sir, for giving me this opportunity to talk on subject hydrology. Thank you, sir. Shall I leave, sir?
Yes.